Okay guys,
Whoa.
so question 18 is 15 factorial minus 9 factorial all over the denominators. What I want to explain to you is what does factorial mean. If I say 7 factorial, what does that mean then?
It means 7 by 7 by 7 by 7.
No, it means 7 by 6 by 5 by 4 by 3 by 2 by 1. Everybody happy enough with that?
Yeah.
Okay. Now, the next thing is you basically use your calculator. So you enter in 15 factorial. Just make sure you're in the proper mode. Press the fraction button first. That's interesting. Okay. Sometimes the fraction button gets occasionally broke, so you go to math LL. I think that fixes it. There you go. Okay, so 15 factorial. Factorial button is here. And then you're dividing that by 4 factorial, multiplied by 11 factorial. And you get 1365. And then the next one, which is going to be 9 factorial. Divided by 2 factorial. Multiplied by 7 factorial. And you get 36. So obviously one of them take away the other one is 29, is it? Oh, sorry. 1329. Everybody alright with that?
Yeah.
It's Mary using the calculator. No big deal. Okay, now what happens next is they have some written questions. The written questions, these factorial buttons actually come in useful. Okay, so give an example. 4 identical laboratories are situated side by side in a straight corridor. The school principal wishes to designate a lab for like physics, biology, chemistry and science. How many arrangements can the principal make? Well, he has a choice of 4 in the first one, doesn't he?
Yeah.
Any of them. Then when you pick one, what happens?
3.
3, 2, 1. That is 4 factorial, isn't it? 4 multiplied by 3 multiplied by 2 multiplied by 1.
Yeah.
Factorial is what the exclamation mark is called. And what we get there is 24. How many different arrangements can be made if the science laboratory can only be at either end? Now this is interesting. Either end.
Which one's your science?
They're all sciences.
Specifically the science laboratory as opposed to the physics. It's specifically the sub, like the junior cert science.
Well, would you know that in an exam?
Yeah, it's a bit ambiguous, but you should know. Like, so it says it in the question that science is.
Oh, it's actually.
Yeah.
You have one. No.
So we can do it 2 ways, alright? Let's do it. Let's do the first way, where science has to be on the left side.
Yeah.
If science has to be on the left side, what does that leave then?
3, 2, 1.
3, 2, and 1, which is 6 ways, yeah? And then if science has to be on the other side, there's only one thing you can do, put science on the right hand side.
Yeah.
And then it's 3, 2,
Wow.
1. And that's 6 plus 6, which is going to give us 12.
So, what was the 4?
Huh?
What was the 4 on the first one?
The 4 was when you were allowed to fill any of the 4 subjects in whichever slot you wanted. So there's a choice of 4 subjects in the first one. If I chose physics as an example to go in the first slot, then there's only 3 left to choose for the second slot. Then when I choose the second one at random, then there's only 2 left for the third slot. If I choose biology then there's only science left for the fourth slot. It's about how many choices you have. You couldn't have physics. This won't work.
Yes.
Because you're only allowed to have one of each. Okay, we'll try another set. So that's 19 and 21. Okay guys, actually, imagine that, first of all, how many different ways can all 8 horses finish? Okay, this is assuming any of the 8 horses can come first. So there's 8 slots, yeah. Okay. 8. There's a chance any of the 8 horses wins, correct?
Yeah.
One of the horses gets picked. How many for second place? 6, 5, 4, 3, 2, 1. Multiply all that out. It's a factorial, which is 40,320. Okay. Is everybody alright with part 1? Any of the 8 horses can come first. Once you choose one of the horses, there's 7 horses left for second position, 6 horses left for third position, etc. Everybody okay with that? Now, the next one is difficult, alright? There's 2 horses that come at the very end. Okay? So, in a way, you can almost say it's like 2 separate races, couldn't you? You could argue that this race here, there's your top 6 horses, and after that, there's your last and your second last. Would you agree with that? So let me explain with this. Okay, so what we have here is how many horses are eligible to come first? 6. Because you're told that 2 of them always come last and second last. How many are eligible for second? 4, 3, 2 and 1. That is 6 factorial. Do you remember the fundamental principle of counting? How many ways can you do one thing multiplied by how many ways you can do the other? That's how many ways positions 1 to 6 can be determined. How many ways can positions 7 and 8 be determined? 2 multiplied by 1 or 2 factorial. Because it doesn't tell you which one's faster. It says 2 horses come last and second last, but they can switch positions. So it's multiplied by 2. 6 factorial multiplied by 2. Anybody?
No.
720?
1,440.
1440, because 6 factorial is 720, and 720 multiplied by 2 is 1440. Okay. The only other one I have to show you is this one here, right? We're going to do this by a bit of discovery, right? This is the best way to do it. We're going to have a triangle first, or a circle with 3 different objects, hence why I refer to a triangle. Is that right?
Yeah.
How many ways can I arrange them? So it's like A, B and C.
Yeah.
Okay, so what other way can I arrange that?
CAB, BCA.
So, did you say CAB?
Yeah.
So C to A to
B.
B. I would argue that's the same thing. Because look what happens.
Oh.
What happens if I rotate it? The B moves with the other one. It's the same combo. So you've called it the same combo twice. Okay? So let's try another combo. Anybody else have another way of doing that?
CBA.
CBA?
Yeah.
Okay, so change the B and the A around. Is there any other combination we can use there? Huh?
B. No.
There isn't, is there?
No.
Anybody see that? No other combo? So, when you have 3 objects in a circle, the number of combinations is
Wait, no.
2.
No.
No, it'll just spin around back to their original position, right? Now we're going to add in D. A, B, sorry, we'll put them in order to begin though. A, B, C, D. Is everybody cool with that?
Oh, yes.
A, B, C, and D. I want you guys to come up with actually, I'll give a pause for a second. Okay, so what we're going to get first and foremost is the sorry, I'll just have to look that out. Go again. Now this should work this time. Okay, so you can see that DABC is actually the same combination as ABCD. So in a way, it doesn't matter. We should fix one of them at the front, because having D at the front doesn't make a difference, does it? If I put C at the front and I said C, D, A, B, it's still the same combination. Would you agree with that?
Yeah.
Okay, so here's what I suggest you do instead. What I suggest you do is you say, I'm going to fix A at the front, and we're going to keep A at the very top position. We're never going to change A out of there. And now we're going to come up with different combinations of A. If we change C and B, does that work? A, C, B, D? So we go A, C, B, and D. Okay. We could change. We could go back to the first one and we changed C and B already. We could change C and D. A, B, D, C. So that's A, B, D, C.
A, D, B, C.
And then you could change, A, D, B, C. So A to D to B to C. Any other combinations? A, D, C, B.
Is that? Yeah.
So A to D to C to B. Is that alright? What's the next one after that?
A, D, C.
There's one more. What about A, D, B, C? No, we already have that one. A, C, A, C, D, B. So A to C, D to B. Now, we overcame this problem by working the following way. We originally have 4 slots, don't we? Would you agree with that? You have 4 slots. But unlike a linear, because it's in a circle, we decided to fix one of them to the spot, didn't we? 1 factorial, yeah? And then we did 3, 2, and 1. Would you agree with that? So the answer was, when you have 4 dots in a circle, yeah, the answer turned out to be 3 factorial. Does anybody remember the answer for when we had 3 dots? 2 factorial. Can anybody in the class make a prediction on what you think the answer for n equals 5 will be? The answer, the question above. 4 factorial. That's correct. When n equals 5, the answer is 4 factorial. Could anybody tell me what the result will be if we have 100 dots that need to be arranged in a circle? 99 factorial. And finally, if we have n objects, there you go. n minus 1 factorial. Okay, so bottom line, the answer up the very top is there's 5 of them. 1, 2, 3, 4, 5. However, we're going to say the answer is 4 factorial, which is what score? 20? 24, isn't it?
24.
Yeah. There you go. Okay, guys.